This is a new section of factoring, and what this stands for is factoring by GCF, greatest common factor, and through the X box. We already saw something similar to this, and I'll show you what I mean as we go through it. All right, so what we're going to be doing is, first of all, when you set up your notebook, this is right after parts of a radical. We did this part in class, so if you don't have these notes, take a moment, copy those, pause it. All right, now factoring GCF and X box. Make sure again you're always filling in your table and updating that as you go. All right, so now factoring. Now let's say I give you a problem like this. X squared minus 4x. All right, factoring means we're going to break it down. Okay, we're going to break it down into its factors. Now, the first thing we always want to look for is GCF. And so what I'm going to do is here make a little column for notes. Is first try to find a GCF, okay? A common factor. Greatest common factor is what this means, okay? So greatest common factor, all right? So I want to look at the two terms that I have here and say, is there a common factor between those two terms? And if you look, they both have x. But the question is, how many x's do they have in common? Well, if I broke this down, I made this x times x, and this just x, well, they both have at least one in common. So if they have one in common, I can divide those out of both of these terms. And I'm going to take x out of this x squared, and I'm going to divide out x from this x squared. And so now I have x, okay, because x squared divided by x would be just x. And then if I divide 4x by x, it will be just 4. And if you think about it, if I distribute this back, x times x will give me x squared, and x times negative 4 will give me negative 4x. And so when you multiply it or simplify it, it should take you right back to what you started with. Okay, so this is pretty much it. We're just looking for those factors. Now, if I asked you for a solution, which would be in the next chapter, you would figure out what would make this 0. Okay, but that's in the next chapter. Okay, so now number 2, let's say I've got 5x squared minus 20x. All right, well, here there was no coefficient except for 1, so there's nothing really in common with 1 and 4, but here I notice that we have a 5 and a 20. So I'm going to start with the coefficient and say, okay, well, what's the greatest common factor between 5 and 20? Well, 5 will divide into 5, and 5 will also divide into 20. Okay, so I can divide out 5. Okay, so that's a common factor. That's the greatest common factor. Remember, you're looking for the biggest number to divide. And then also x squared and x, they also share a common factor of at least 1x, just like this one did. So I will divide out an x. Okay, so the common factor goes in front of your parentheses, and then I divide 5x into each of these terms. So it's almost like I'm doing divide by 5x, divide by 5x. Well, 5 divided by 5 is 1. X squared divided by x is just x. 20 divided by 5, well, that's 4. And remember that bring down your sign, negative. And x divided by x is just 1, so it's just 5x and x minus 4. Okay. Okay, now, let's say I've got 2x plus 10x plus 8. All right, now I have 3 terms. Is there anything in common? Well, if I look at these coefficients and this constant, I can divide 2 into all of those. Okay, now do they have x in common? No, because the 8 doesn't have x. Okay, so I'll just divide 2. So divide 2, divide 2, divide 2. And 2 will be my common factor that I put in the front, or GCF. And this divided by 2 is 1, so just x squared. This divided by 2 would be 5x. This term divided by 2 would be 4. Okay, and I don't want to stop there. Then I want to take a look, let me zoom in a little bit, and see, can I factor out this part? Okay, well, we practiced that the other day, and we have to say, all right, can I break this down further back into binomials? Okay, well, I'm going to use a little trick that you may have seen before. And what I do is I take your last term, okay, and this is called factoring in trinomials. a binomial is 2 numbers. A trinomial is 3 numbers. Okay, so what I do is I take my last term, and that goes on the bottom. I take the middle term, and that goes on top of my x. Now what I'm trying to do is I'm looking for what 2 numbers could I multiply to equal 4, but the same 2 numbers have to add up to 5. Well, I know 2 times 2 is 4, but 2 plus 2 is not 5. So the only other way is 4 times 1. If I do 4 times 1, that's 4, and if I add these two, that's 5. Now, when your leading coefficient, okay, on the x squared is a 1, all I have to do is take these numbers and put them right into the binomial. And we practiced this the other day in class. Okay, and there is my final broken down factored polynomial. Okay, so now let me give you an example where it's just the trinomial by itself. Okay, so let's just say I started with this alone. X squared plus 7x squared, oops, sorry, not 7x squared, just 7x plus 10. Okay, well, some of us are able to see what the factors are right away. Okay, some of us might need to use the x, which is fine. Here, I would say, okay, 10, that goes on the bottom. This, your last term, and then the middle term goes on top. Middle. 2 numbers that add up to 10, multiply to 7, will be 5 and 2. And because there's just a 1 right here, okay, just a 1, I can take these 2 numbers and put them right into the binomial. Okay, and there is my polynomial factored out. Okay, and I'll say only x is needed with leading coefficient of 1. So as long as that first number is 1, that's all I have to do. Now there are cases when that's not all I have. Maybe I've got a coefficient that's bigger than 1. Okay, now I've got to do something a little bit different. Okay. All right, so I'm going to go ahead and do my x. Okay, so now, just so you know, the final answer will end up being 2 binomials. Okay. However, when I do the x, the number on the bottom is not just the last number. Now, technically, if I go back and look at these, the last number that goes here is really the last number times the first number. So if I did 4 times 1, that's just 4. If I did 10 times 1, that's just 10. In this case, I have a number in the front. So 2 times 3, that's 6. And then the 7, the middle number still just goes on top. Now think to yourself, what 2 numbers multiply to 6 but then add up to 7? Well, 2 times 3 is 6, but that doesn't add up to 7. So just 6 times 1. Okay? Now, when you have a number bigger than 1, you need to do an extra step. You can't just put these numbers right into the binomial. You have to do what we call the X and box. So that's why we like to call it the X box. Okay, so you guys know this box. We did it with dividing. So what you're going to do is those numbers, those 2 numbers, go into the corners here, 6 and 1. And what you do is you put an x on those numbers because these 2 numbers, 6x plus 1x, gives you 7x. Now what you do is you take your first term, that goes in this box. Okay, and your last term goes in this box. And guess what? We're going to have to find the numbers that go on the outside. So think about dividing polynomials. All right, so I have to first think to myself, okay, what 2 numbers multiply to give me 2x squared? Well, I know that 2x times x gives me 2x squared. But the question is, these are different numbers, so where does that 2x go? Does it go on the top or on the side? All right, well, let's say I put it right here. Let's say I put 2x there. Then I have to say, okay, well, 2x times what number would give me 1x? Well, it would have to be like 1/2, but we don't want fractions. So what that means is that you just put the 2x on the top instead of the side. So it's like a puzzle. You got to figure out where they go. So now that means the x goes here. Because then 2x times 3, well, that works because that gives me 6x. And then x times what gives me 1x? Well, just 1. And there's my binomial factors. So those go here. 2x plus 1, and that's x plus 3. And there's my final factored polynomial. Okay?